We're going to be creating React TypeScript project. We're going to set it up from scratch, and we're going to use the Create React App template. It's good to know how to create it from scratch because it really gives you a better understanding of the working pieces. Inside we have the React, the TypeScript, the Webpack, and the bevel. The end result is going to be three components that we're going to be creating. One is a stateless React TypeScript functional component, one with prop, and a clock. So to get started, the first thing we need to do is create a directory anywhere you want, and we'll call it TS for TypeScript clock app, and change directory into that new directory. Then we're going to create an output directory. We're going to call it dist for distribution, and then we're going to start the project with the npm init -y, which will create our package JSON file, and it's going to include all the different initial setting. The next step is we would like to install all the components that we need. The first set of components we're going to be installing is the React and the React DOM. Now you can use either npm or you can use yarn. With yarn, you just do yarn add React and React DOM. Once the installation is complete, so beside the React and React DOM, we need few things such as the declaration file types for the React DOM. We also need the Webpack. So that's the open source JavaScript module bundler that will create our distribution package. We need TypeScript itself. Then we also need the TS loader, so it helps the Webpack compile different file types. So we need the TS loader to compile the TypeScript code using the TypeScript standard configuration file that we're going to be creating. And we need the development time dependencies, the TS loader, and the source map loader. So to install all of that, we're going to be using, again, you can use npm. I'm using here yarn. So just do the add. The --dev means that it's going to keep a copy on our JSON file. Once that installation is complete, we also need one additional file, which is the style loader. We did the TS loader, but we didn't do the style loader. The style loader will enable Webpack to process style sheets because we're going to be using CSS. You know, we're doing everything from scratch here, so you need to, anything you're going to process, if you need to process images, anything you need to process, you need to add a loader that Webpack knows how to handle that. The next step is we need to create our TS TypeScript config.json file. That file is going to give instruction to the compiler where to compile the TypeScript files into JavaScript. So the compiler will take out TypeScript and turn it into JavaScript that the DOM can handle. There's different compile settings that you can set. I'm going to be setting the minimum. We need to tell it what's the output directory, which is going to be the distribution folder we created. We need to tell it if to use a source map, and we need that source map. And we need to set the target, what kind of compiler we're going to be using, and who's going to handle the JSX file. Once that's done, the next thing we need to do is we need to create our Webpack config.js file. For the Webpack config.js file, I left a copy on the GitHub. We're going to be using the curl command output flag to download that file into our directory. And that file, I use the file that they provide on the typescriptlanguage.org. In the handbook, they have a sample config file. So I use that and I made changes on top of that. Now, before we set it up, I want to point out that the Webpack, they change their API very often. So that Webpack config.js file may need to be updated all the time, every time that they change Webpack version and API. The version that I'm using is 4.43.0 for the Webpack and 3.3.12 for the CLI. It can change, again, as I said. On the Webpack configuration file, I just took one from the handbook. It was missing something. It didn't have the loader for the CSS. So that I added manually. Now, if you would like to use SCSS or SASS or whatever style sheets you would like to use, you're going to need to set the loader. After you set the loader, Webpack will know how to handle that, and you need to set it in the config file so Webpack will know how to handle that. That goes for any file type. Let's say you want to add images, whatever you want to use, you're going to need to give instruction, and that happens on the Webpack config.js. Now we have our project ready. The last thing I'm going to do, I need to create a directory where we're going to put all our source files. So I'm going to create a directory. I'm going to call it source. And once that's done, we're really ready to work on our project. Our next step is to import our project into your favorite IDE, and inside you'll see our project. Here's the folder structure, what we created. Now we have an empty project, so we're going to create a file. The first file we're going to be creating is going to be the app.tsx file. The TSX stands for the TypeScript, and that file is going to be our first component. What it's going to do is we're going to use it to show a link. Again, the TSX, that's the TypeScript file extension. The functionality we're going to be writing in that component, it's going to be really pure JavaScript function. So it's just that the file extension change. So if it was .tsx or it was .js, the code didn't change. I'm using the same code. I'm not going to be putting any TypeScript. We just want to see something up and running. Code level, we're just going to import our React, and we're going to use JSX to return a div that's just going to hold a header, and the header is going to have a link to the GitHub repository with this sample code in this tutorial. We're also going to need to create another component, the index.tsx component, to render our app.js code into the DOM. This is the same as we would do with the JavaScript file, right? In a typical React application, we would have the index.js file that does the same thing. Again, I'm not writing any TypeScript code here. It's just that the file extension is TSX, and it just render component, the app component, add it into the DOM. Then the last thing we need to do, we need to create our entry point. So we need to create an index.html file that will include a div with the ID root, so we can render our app and our code into the HTML, into our browser, so we can actually see the results. That needs to include, if you look at the file, we add our dependencies, which is the React development and the React DOM development. We point to our distribution folder because the Webpack is going to take our file from TypeScript and it's going to compile them into JavaScript. So we're going to take our output right from the distribution folder so the browser can understand our code, because the browser doesn't know TypeScript, it knows JavaScript. To see all of this in action, we're going to just call yarn and Webpack, and that's automatically yarn is going to call the Webpack config file, compile the code, or you can use npm. If you use npm, it would be npx Webpack instead of yarn Webpack. Once you run that and it compiled correctly without error, to see our current app, just open the index.html in your favorite browser, and you should see a link there, that's the page we created, the component we created, and that link takes you to the GitHub repository with the code in this tutorial. We created our React TypeScript project from scratch, and it was really good exercise because it shows us all the working pieces of the React, the TypeScript, the Webpack, Bevel, the compiler, what we need to do to get a project up and running, what our configuration file, like our package JSON file, the libraries that we need, the loaders that we need, all those things, we really saw it by building it from scratch. But realistically, when we create an app, we really don't need to go through this entire exercise, because Create React App CRA is the standard, and it removes all the headache of setting up and configuring our project, and it creates us the local server with the live update. So when we make changes in our files, we won't need to keep compiling the file. It will compile them automatically, and we can just go to the web page and we'll see the changes updating automatically. It already includes all the libraries that we need. It has all the boilerplate template code. It has everything we can possibly need. Again, we can install it with npx or we can install it with yarn. Only thing we need to do with the Create React App that is different than a regular project, if you want to use TypeScript, is just use the --template TypeScript. So we're just using the template TypeScript flag, and that will create our files with the TSX extension, file extension, instead of the JavaScript file extension that it normally would do. In terms of the code, it's going to be the same code, because functions inside of our app and our index components really won't have any specific TypeScript code, but the file extension will change. And there's going to be additional libraries and the compilers and everything we need in order to write TypeScript code. So once the installation is complete, then just change directory to the project you created, and you can either again use yarn or npm. You'll do yarn start or npm start, and then if you go to your favorite browser and just type in localhost on port 3000, you'll see the project. If you have an existing project, then you can also transform it into a TypeScript project. What you're going to be needing is you're going to need to add the types for the React, for Node, and for the DOM, and for the Jest. TypeScriptLang.org has a playground, and that playground allows you to run your code, and the compiler will compile the code from TypeScript into JavaScript. You can see it here. If you open up the console, so right click and inspect it and open up the console, and hit run, you can see that code, hello world, right? And you have examples here, so you can play around and look at all the different examples. And also you can configure the compiler, what's the target, the language, all the different compiler option, the strict mode, so you can configure all that stuff and play around with it. Now the example that I'm giving, if you take all my example of the GitHub and you copy them into the playground, it's gonna compile them into JavaScript, and if you run them, you'll see the result, right? So hit the run, and you can see all the results here. Naming convention that I choose, I use the Shakespearean type naming convention, so it's easy to understand. But generally speaking, when you look at JavaScript, it's a scripting language. TypeScript is a full-blown programming language. To be more specific, JavaScript only includes 8 dynamic runtime types. It's the big int, boolean, integer, null, number, string, number, and objects, right? And TypeScript, it adds static types to JavaScript by setting a compiler to type checking the source code to turn it into dynamic. So we have additional. So if we look at primitive types, for example, boolean, so if we set a flag here and we set the flag to true, we don't have to type the boolean because it's inferred that it's a boolean. So you see, if we do look at flag 1 and flag 2, it's the same, right? Because it's inferred that it's boolean. On the JavaScript side, it looks the same, right? We have constant flag 1 equal true in both of them. And the same thing, if you can create a type in TypeScript, so you can create your own type. For example, here I created a type, I called it a year, that it's a number, and then you can use the type that you created, and it's all about creating your type. And the same with non-primitive, with object types. Object could be functions, array, anything that it's an object-oriented, right? And you can also do the same thing, right? You can create an array, you can create an array with 2 values like we have here. So I suggest you just go through all the different examples and get yourself familiar with, as well as play around with the example that they provide here, and that will give you a really good understanding about TypeScript before you move on into integrating TypeScript into your React project. Custom components are the heart of React. We're going to be creating 3 types of component. We're going to extend the React component API, and we're going to get out-of-the-box functionality. It can still get confusing, so we're going to be working with 3 types of component. The first one is going to be a stateless React TypeScript functional component. The second is going to be a stateless React TypeScript functional component with props, and then the third one we're going to create a TypeScript class component with props. So to create the stateless React TypeScript functional component, we want to use as little TypeScript as possible, and we want to use JavaScript as much as possible. So the most simple example that I can think of is if we create a functional component that just hold a JSX code, a div, and then we add it to our renderer, that will show us the output of that. So to do that, we're going to create the functional component without props, and then we're going to add that tag into our renderer. And once we compile and go back to our index.html page, we can see that showing on the screen. Then the second one we're going to be creating is the functional component with the props. So this time what we're going to be doing is, it's very similar, but we're going to create an interface. So we're going to use TypeScript to create an interface. The interface is going to hold our props. We're going to use name as our property, and then when we create our functional component with the prop, we're going to use the .fc. So the .fc is based on the React functional component interface, and the RFC includes a signature for our function that returns the value of the JSX. So we can pass the type of our prop either inline or by supplying an interface type. Then compile again and refresh, we will be able to see that. The last component we're going to be creating is going to be a React TypeScript class component with props and state. The third one that we're going to be creating, we're using the class component, and we're actually starting to write TypeScript code. Here we're going to have two files. We're going to have the clock TSX file, and we're going to have a CSS file. On the CSS side, we're going to be creating a clock face of a circle using the border radius. So when we set the border radius to 50%, it's going to create us a circle. Set each one of dials, we're giving it a color, and we're setting the style for it. And we can, if you like, you can use an image on the div instead of drawing it, instead of using the styles. But for simplicity, we're just using simple style of border, which is only going to be 1 pixel, 2 pixel for the minutes, 3 pixel for the hours. So we'll be able to see our analog, and we're setting the colors. On the TypeScript class, on the clock TypeScript, the code, we extend our React component and we get out-of-the-box functionality. So those are automatically available for us. We're going to be using the component will mount. That function is called before the component mounts. So that's how we're going to initialize our state. We're going to call the component did mount. So after the component did mount, we're going to set the state on each 1 second tick so we can update our clock. And we're going to use the component will unmount, which is once the component is unmount, we want to remove the timer because we want to avoid any memory leaks or that interval that we set to be staying there. Then our method, they handle a clock tick by setting the state. That's the method that's going to update the state based on our date. If there's a time zone difference, it's going to add that we can set it from our index, from our entry point. And we're going to set our hour, minutes, and second state. And once that state is being changed, it's going to reflect automatically on our JSX code when we render it. And using the brackets we have there, the changes in the data will show us the clock changes. Couple of things to notice is, on the JX side, we create a rotation. We use the style of the div to set each dial. We use the transform and we use the rotation. For the minutes and the second, there's 60 seconds, there's 60 minutes, so we use the 6 degrees. On the hours, so it's 12 hours times 30 ticks will give us 360 degrees of a circle. The last thing we need to do is on our entry point, we want to add the clock component into the renderer. It's going to be added to the root, and we'll be able to see that. Compile again and refresh, and we can see our clock working.